In this section, we'll solve a couple of questions regarding number of ways to color a cube. The reason why many students get confused in these questions is because they're not able to distinguish between two scenarios. So we'll first discuss the scenarios and then we'll have a look at the questions. So the first scenario is what is there on your screen. So if you look at the cube on the left hand side and the cube on the right hand side, is there a way you can tell whether both these cubes are same or not? Can they be similar? And the answer would be yes. Probably they can be similar. You can never be sure without looking at all six faces. But just by looking at these three, we can say that if I turn this cube in this direction and then turn it in this direction, probably I'll get the yellow face on top, the red where it is here, and the black face on the right hand side. So there is a possibility that both these two cubes may be same. So if I were being asked the number of ways to color this cube, the left hand side and the right hand side might comprise only one case and not separate cases, because I can always reorient the cube on the left to look like the one on the right. So that is one scenario where the faces are not distinguishable. Each face can be moved and made to take the place of the other face. There is the other scenario where we have some ways to identify each of the face. It can be something written on the face. It can be that each of the face is rigid and points in one direction. There is a way to identify each face. In this case, I can never make the left-hand side figure look like the right-hand side figure, because face with digit 1 is marked yellow in the left-hand side and face with digit 1 is marked red in the right-hand side. And there is no way these two cases can be the same. So here, these two cases will have to be counted separately when we are doing our countings. While attempting a question on painting a cube, you should ensure that you know which scenario you are dealing with. And there will be hints in the question which will indicate whether the cube has some identifiers for each of the face or whether you can reorient the cube to look like another one. Let's look at questions and that would make it clear. Here, what is given in the question is the cube is marked with 1, 2, 3, 4, 5, and 6 on its 6 faces. So each of the face has a distinct identity. And that's very important information. And in general, it makes the question much more easier for us. Let's see how we'll approach this. The first part is how many ways can we paint it with 3 colors? So there are 6 faces. Each face will be painted with 1 color. How many ways can we paint it with 3 colors? We can choose the first face and paint it in 3 ways. And then we can choose the second face and paint it in 3 ways, and so on. So the number of ways you can do this is 3 to the power 6. So this will be the answer for the first part. The second part adds another condition. The second part says if the adjacent faces are painted with different colors, in how many ways can the cube be painted using 3 colors? So what it's saying is that if I paint one with red, face number 1 with red, I cannot paint the adjacent faces with red, which would mean I cannot paint 2, 3, 4, and 5 with red. You follow the same chain of thought for 3 colors, and you'll very quickly realize that the only way to paint the cube becomes that you paint the opposite faces with the same color. In the way I have written the numbers, 1 and 6 will be of the same color, 2 and 4 will be of the same color, and 3 and 5 will be of the same color. The number of ways to do that would be 3 faces. You choose the first face and give that to first color. And then from the remaining 2 faces, you choose another face and give that to the second color. And then the remaining face goes to the remaining color. And so the number of ways becomes 6. The question will be solved differently if the faces were not marked. And that we'll see in the next question. Let's look at this question. So again, we have a 6-sided cube and 6 paints of color. And we want to paint each of the face with a different color. However, the difference in this question from the previous one is that here it's mentioned that if you reorient the cube to look like another cube, then the 2 cubes are not distinct. So each face doesn't have its own identity, and if I can change it by 90 degrees or 180 degrees to look like another combination of colors, then these 2 will be considered the same. Now let's see how we'll approach this question. Before we get started, you should know this formula, which is covered in permutation and combination. For circular permutations of n objects, n minus 1 factorial is the number of permutations that is possible. Now let's see. The way I'll do this is I'll fix one color on the top surface. As in, on one surface, I'll say that this has to be color 1. And the reason why I can do this is because I know that color 1 has to be applied on one face. And if it has to be applied on a different face, I can always reorient this cube to take the face to that point, and it will be the same thing. So I'm fixing this face as color 1. Once this is fixed, how many ways can I choose the color of the face exactly opposite to that face? And that will be one of the remaining 5. So if 5C one way, I can choose the color of the face exactly opposite. And now there are 4 faces left and 4 colors left. But these 4 faces are in circular arrangement, right? These 4 faces are in a circular arrangement. So I can paint them in 4 minus 1 factorial, which is equal to 5C1 into 3 factorial equal to 30. So there are 30 ways to color this cube distinctly. The question is not as simple as it looks in the answer, because the thinking that has to go behind it is not very straightforward. So make sure you spend some time thinking through why I was able to fix a color and how I was able to use circular permutation, why 5C1 was there. And also please note the difference between this question and the question that we did previously, where each of the faces were distinct. You should also be able to solve the question if we had 10 colors to start with. In that case, you would have chosen the 6 colors and then arranged them in 30 ways. So the answer would be 10C6 into 30. With this, we have covered the second part of our agenda, which was questions around painting and permutation and combination. You can have a revise this lecture, and then you should hopefully be able to solve most of these kind of questions. There might be modifications. Questions can be far more difficult, but I don't want to get into them because I don't think they're very important from CAD perspective. But otherwise, you know the basics that are needed for solving these kind of questions. In the next section, we'll do some difficult questions on cubes.